going to talk today about angles, lesson 1.3. And we're going to have some definitions, and we're going to draw a diagram and stuff for some of these here. The first one says a degree. And typically you're used to seeing degree. It's a unit for measuring angles. And what it is it's a little circle up at the top. So it looks like that. I'm probably better if I say something like 45 degrees. 45 degrees. That little symbol right there that indicates the degree. Last week many people asked about array, because I said technically we haven't talked about this yet, so luckily here it comes. Array has a starting point, but then it continues on in one direction forever and ever. So it has a starting point, but no end point. Something like this. A starting point, and then it continues on. And in fact, if we get a little bit more specific here, we might call that A, and then another point there, B. And when we indicate how a ray is denoted, how we show it, we could say A, B, and it's with a arrow with an arrow on top of it. An angle is made up of two rays with a common endpoint. And it's going to infringe in the space of sides, but that's going to be okay. Here's an angle. And it's going to have a common endpoint. So if I keep with the A there, our vertex is vertex A, and I've got another diagram in a moment to label it a little bit better. If we want to name an angle, and I didn't do necessarily the best with my points here, but I'm going to say, I'm going to put B here and C there. An angle is denoted with kind of an angle there. Maybe it's a sideways V is how I write it. And what we would say is we would say angle BAC. The vertex, which is the common endpoint, needs to be in the middle when we write this angle. Every single time. So when we get to the sides here, still looking at that red angle, what happens is that the rays that make up the angle are sides AB. So ray AB is a side, as well as ray AC is a side. And I do want to put A first because A is the starting point. We continue on forever through B or through C, but the starting point is A. And then again, our vertex of the angle, the vertex is A. It's the common endpoint of the angle. Again, when we write angle, it needs to be in the middle. Now, some special angles. Right angle. Well, it has an angle of 90 degrees in it. And there's that degree symbol. It oftentimes is indicated with a box in there. An acute angle is an angle with the degree measure less than 90 degrees. Obtuse, it's an angle with the degree measure that's going to be more than 90 degrees and less than 180 degrees. I know my line's not long enough, but I hope that you can fit that in on your paper. More than 90 degrees, but less than 180 degrees. Because 180 degrees is that last angle on there, a straight angle. It's an angle with a measure of 180 degrees. So as we skip down to the next part here, I said that I have a better picture here. And it actually ended up to be the same picture roughly that I had. Here it says you can name angles by the vertex. And notice where our vertex is. It's that common endpoint of the angle, vertex A. We can also name it like we did with the symbol, and then angle BAC, the A being, the vertex being in the middle of that. And then we also happen to have a number here at that vertex, so we can name it by that number 4 there. So let's take a look at our first example here. Use the diagram at the right to answer the following. Name the vertex of angle 2. Well, here's angle 2. We're looking particularly at this angle in here. So the vertex of angle 2 is M. If we want to be a little bit more specific though, in fact I'm going to put the angle symbol there, angle M for our vertex. If we want to be a little bit more specific, because M is more than one place, so to speak, in terms of angles, then I might say angle KML. And then over here on part B, it says give 2 other names for angle 1. Well, here's angle 1. Notice I'm putting kind of a little curved arc in there, which we may get into today or maybe it's tomorrow. But when we look at this, I might say angle JMK. Again, JMK, the M. The vertex needs to be in the middle. Or we could say angle KMJ. The big thing is, we need to have our vertex in the middle of those 3 values right there. Back to geometry. Use the diagram below or beside here to answer the following. Name 2 different angles that have a vertex of point L. So specifically here we're looking at this, and P, L, K. Another possibility, Q, L, M. And remember, those aren't the only two options. E, N. And right on top of it, we can also have P, L with an arrow on top of it. That indicates that we're working with a ray. As we flip our papers over, we're going to classify each angle as right, obtuse, obtuse, or straight. And I hope what you see me doing will be helpful for you. I just like to take my finger and outline what we're looking at. U, Z, W. And as you see on U, Z, W, we have that little box in there. And because we have that little box in there, this means that we're going to be working with that right angle. If we look at Y, Z, U, we're measuring from here to there, and that looks like it's going to be an obtuse angle. The next one is T, Z, Y. Well, again, as we highlight that with our finger, or at least mentally look at that, T, Z, Y is a straight angle, which leaves us with U, Z, T, and U, Z, T happens to be acute. Again, a reminder, acute is an angle that's less than 90 degrees, and an obtuse has to be greater than 90, but less than 180. Number 4, use the diagram to the right to answer the following. It says name 2 different angles with vertex of R. And once again, a reminder, as we name them, if we are using, and we are going to be in letters, the R needs to be in the middle. And that we're going to write down 2 of them, but there could be many of them. Just because your 2 angles don't match the person sitting beside you does not mean that you are wrong with respect to those angles. But if we look at this particular one, 2 different angles with vertex of R. Well, I did S, RC. Angle, S, RC. How about D, R, S? There's other ones. We could do SRM. We could do SRQ. There's lots of options on this one if you didn't happen to write down the same thing as me. Letter B. Name the line that contains point B in 2 different ways. Well, find point B on here, and then we're going to indicate our line. Well, one of them we can say is QB. Don't forget to put an arrow on both ends when we indicate a line. We don't have to have B in that particular problem. We could say A, B, line A, B, with our notation of arrows across there. As you look at that, you see that B is in between A and D. And again, those aren't the only options. Letter C. Name 2 line segments that contain point C. Just a reminder, line segment has that symbol if you want to get technical. It's got a point at the end and a point at the end. I do not write those. Just do a straight line. 2 line segments that contain point C. Well, we could keep it real simple. We could say UC. But there's multiple ways. We could say VR. We don't have to have C written. But that symbol, that line with no arrows over it, means that we're dealing with a segment. Name 2 rays that contain point Q. Well, finding point Q, and then we look at a ray. Again, start with Q. And then we could say Q, U. 1 arrow when we write it. We're starting at point Q and we're continuing. We could also say ray Q R. We could say ray QV. We could say ray QA. We could say ray QM. There are lots of possibilities on these. Are points V, U, and S collinear? V, U, S, are they collinear? No. Are points M, R, and D, M, R, and D collinear? Yes. And finally, name an acute angle. Again, multiple choices for answers on here. Angle, P, Q, A. Quickly done. An obtuse angle. An angle that is more than 90 and less than 180. And I did angle M, R, oh, maybe I didn't do that. Let's see. Let's do angle W, V, M, and then a straight angle. We can do angle A, B, C, angle A, B, D. Again, multiple choices here. Just because your neighbor doesn't have the same answer as you does not mean that one of you is wrong.